All right, so we are going to go ahead and talk about taking equations that are written in complex form and converting those to be writing them in what is called polar form. Polar form is going to be this right here where we have this r cosine theta plus I sine theta. So I need to have some r value. So that's going to be the distance from the pole in the center to wherever I've placed my point. And then the theta is giving me my angle measure from my polar axis. So let's go ahead and see. What I've got here for this very first one, it says I'm going to convert 2 plus 2i to polar form. So this is in A plus BI format. So remember, if I'm putting this into polar form, I've got to have an r and a theta. Well, this is no different than stuff that we did previously in terms of taking it from being in complex form and putting it into finding a polar coordinate. So I'm going to do the same exact process, except I'm not going to put it as a coordinate. I'm going to put it into this format of this r cosine theta plus I sine theta. So we find r by doing the square root of x squared plus y squared, correct? So in this case, instead of being x squared and y squared, it's going to be a squared plus b squared. Now, b is just the value that is directly in front of the I. It does not include the I. So I'm going to do r as I have a squared is 2 squared, and then b squared is also 2 squared. So 2 squared plus 2 squared is 4 plus 4, so that's the square root of 8. Now remember that we do need to simplify our square roots. So that square root of 8 is going to simplify down to the square root of 4 and the square root of 2, which gives me 2 square root 2. Now, once I have this, I also have to remember that I've taken the square root. So let's go ahead and make this be a plus or minus. It can be either positive 2 root 2 or negative 2 root 2. All right, now I need to go ahead and find my theta. Remember that theta is done by doing arctan, and it's going to be y over x. And in this case, that's b over a. So we're going to do theta, and that's going to be our arctan. And we're going to do 2 divided by 2. Well, that's just 1, right? So I'm looking for the arctan of 1. So where is tangent equal to 1? Well, that's going to be at pi over 4. Now, be careful. Notice I'm saying it's at pi over 4. I have to make sure, is pi over 4 going to be in the correct quadrant to correspond with something that is 2 plus 2i? If I was to plot 2 plus 2i on my complex plane, so let's look at this grid over here. Ignore the circles. The complex plane would be just underneath that, where this is going to be my real axis, and this would be my imaginary axis, right? So if I was to do that, if I plot 2 plus 2i, that means I'm going right 2 up 2, right? That's putting me right here. Well, that's in my first quadrant. So pi over 4 works for that because pi over 4 is in my first quadrant. Now, what if I had negative 2 minus 2i, just like I do down here in the bottom? Well, let's look. So if I was to do that one, let's go ahead and just do arctan. I have negative 2 over negative 2. And that's going to go ahead and get me the exact same thing, right? Arctan, negative 2 over negative 2 is still 1. And so that gets me pi over 4. But notice, if I do pi over 4, that puts me right here in this first quadrant. But if I plot this point here, this negative 2, negative 1, well, that's going to be at negative 2, negative 2 right here. That's in my fourth quadrant, or not fourth, third. Okay, that's in my third quadrant. So pi over 4 is not in my third quadrant, is it? So this is kind of where we're having to decide what's going to work best for what we have. Let's go ahead, and before I go any further, let's figure out what my r value would be here. Well, since it's a 2 plus 2i, negative 2 minus 2i is going to get me the same thing, but I'll go ahead and show you that. We would do the square root of negative 2 squared plus negative 2 squared. And that still gets me the square root of 8, right? And the square root of 8 is still plus or minus 2 square root 2. So Here, if this is my r and if this is my theta, think about it right now. If I was to go ahead and do this as 2 square root 2 and pi over 4, if I did that as a coordinate point, my polar coordinate point, well, that's going to put me right here where this green one is, right? That's going to go right 2 root 2, or I'm sorry, out 2 root 2 and to angle 4, pi over 4. Ugh, I can talk. But that's not what I need in this case. That works for this first one, but that's not what I need for this third one. Instead, for this third one, I can keep it at pi over 4 if I want to, but I have to use a negative r value, right? Because if I do a negative r value, that means that I'm on the opposite side of that angle. So this pi over 4 instead would put me over here with a negative r value. So that's one way that I could do this. I could also go ahead and instead of keeping that at negative 2 root 2, I can make that the original positive 2 root 2, but instead I'd have to change that pi over 4 by adding pi because that's going to bring me from here over to here. So instead this would be at 3 pi over 4. Oh, wow. Apparently I just need to get some sleep. 5 pi over 4. Okay, so that's what I'm going to have for those. But those would be my coordinates. Now let's talk about putting this into our complex polar form, okay? So now that I have an r value in this first one, which is right here at this 2 root 2, and I have my angle measure, this pi over 4, I'm just going to drop those right here in the equation, just like this. So I'm going to have 2 square root 2, and then it's going to be cosine theta, so pi over 4, plus I sine theta pi over 4. And that's all I need to do. That gets me my equation in polar form, okay? For this third one, what I would do is the exact same thing, except I can't use this pi over 4 unless I'm using a negative r, or I use the positive r and change this to 5 pi over 4. I'm going to do what I think most of you will do, and I think most of you will go ahead and get the correct angle measure and keep your r value as positive. So the correct angle measure here would be 5 pi over 4. So I'm going to go ahead and write this down as 2 square root 2, because there's my r, then cosine 5 pi over 4 plus I sine 5 pi over 4. Now, notice the difference between this equation and this equation. The only difference is that angle. I can change either one of these to be the other one just by changing a positive or negative in specific places. So just be careful. Make sure that whatever you have has the correct r value that corresponds with the correct angle. If you need it to be a positive r because you have an angle that's going to be in the quadrant you need, then do that. If you are trying to just keep your angle whatever you get and you need to be over on the other side actually, then that's when you'd have a negative r. Let's go ahead and look at number 2 here. So I've got 3 minus root 3i. So my r, I'm just going to go ahead and do the square root of 3 squared plus square root 3 squared. Well, that's going to get me 9 plus 3. So I'm going to take the square root of 9 plus 3. Well, that's going to go ahead and that's going to get me the square root of 12, right? Now, 12 is going to reduce down, and that's going to get me a plus or minus 2 square root 3. So it's very close to what we had over here, except instead of 2 square root 2, it's 2 square root 3. And then I'm going to find my angle, and that's just going to be my arctan. And I'm going to do negative square root 3 over 3. I should recognize that that is going to be a value that we're used to seeing when we do our values on our unit circle. So for this one, this is going to end up getting me where tangent is equal to negative root 3 over 3. And that's going to be at any of our reference angles using pi over 6. Now, since this is negative, we're going to say it's negative pi over 6. Okay, because remember, tangent is negative in quadrant 4 as my exact value. Sure, it's also negative here, but if I'm saying arctan, that means that I'm using one of my exact values, which is only going to have those restrictions of quadrant 4 and 1 between negative pi over 2 and pi over 2. So now what I've got here for this one, if I write this out, I'm going to have my r is 2 square root 3 cosine, and it's negative pi over 6. Well, let's make sure. So if I go to plot this 3 negative root 3, sure enough, it's going to be about right here on my complex plane. And so that's okay. I'm going to go ahead and keep this as negative pi over 6. And then I have plus I sine negative pi over 6. Now, I know that there's a lot of different ways that I can do the same exact thing with these polar equations and polar coordinates and things like that. They can all be written so many of the same exact equation, just a different way. So I could also, instead of having negative pi over 6, I could do 2 square root 3 cosine. Well, what is negative pi over 6 coterminal with? It's coterminal with 11 pi over 6 plus I sine 11 pi over 6. So that's what I've got for that. Right here, I have the exact same equation, just written twice, just with a different angle measure. They're just coterminal. I could also take that entire thing and I could make this be negative 2 root 3 and use the coterminal angle over here, or no, I shouldn't say coterminal angle, but the one that's going to be over here on the opposite side, that's pi away from negative pi over 6 and 11 pi over 6, and that would be 5 pi over 6. It could also be negative 7 pi over 6. So you see what I mean? There's a lot of different ways I can write the exact same thing. It's just sometimes a matter of finding what's easiest. Okay. All right, let's go ahead and look here. So this says that I need to convert 4 cis 2 pi over 3 to standard complex form. So this is going backwards. This cis right here is just saying I have 4 cosine 2 pi over 3 plus I sine 2 pi over 3. That's what I've got. Well, if I'm going to put this into standard complex form, the easiest way to go ahead and do that is to simplify what I have inside my parentheses here with my exact values that I have on my unit circle. So if I have 4 here, what's the cosine at 2 pi over 3? At 2 pi over 3, it's negative 1/2. And then I'm going to do plus I, and then sine at 2 pi over 3 is going to be the square root of 3 over 2. And now I just need to go ahead and just distribute this 4 and simplify. So if I do that, I'm going to distribute that 4 to both of these. And so 4 times negative 1/2 gets me negative 2. And then 4 times the square root of 3 over 2i is going to get me 2 square root 3i. Proper way of writing that really should be 2i square root 3. But writing it either way is perfectly fine. You just need to make sure that the I is very clearly not underneath the square root. But this right here is going from polar form to complex form. Let's try this next one right here. So it's square root 8 is negative pi over 3. So that means I'm just going to go square root 8 cosine negative pi over 3 plus I sine negative pi over 3. Well, let's go ahead and see what we've got here. Square root 8, I need to simplify that. That's 2 square root 2. Cosine negative pi over 3. Cosine at negative pi over 3 is going to be negative, no, not negative, positive 1/2 plus I, and sine negative pi over 3 is going to be negative square root 3 over 2. And then I'm just going to go ahead and distribute this 2 square root 2 right behind here. So if I did that, I'm going to have 2 square root 2 divided by 2 plus I, and then this 2 square root 2 times negative root 3 over 2. That's a little bit of a lot to try and do in your head for a lot of people. So if I do 2 square root 2 times negative square root 3 over 2, let's look at that. So remember, if I'm multiplying fractions, I just go straight across on both of these. So my numerator goes to my numerator, my denominator goes to my denominator. So really what I have up top is I have that 2 times a negative 1, so that gets me negative 2. And then I have square root 2 times square root 3. Well, remember your rules for multiplying radicals. You can combine them by multiplication. You can't combine them by addition if they're different underneath. So the way that I always remember the operations that I can do with square roots is if I have the exact same number here for a square root, so like square root 2 plus square root 2, I can add them together just like I could add x plus x, okay? I can also multiply them together just like I could do x times x. This would become x squared. This would become 2x, right? Now, if I have square root 2 plus square root 3, that's no different than if I had x plus y. So if they're different underneath the radicands, they're going to be different just like they would be a different variable. Now, I can do x times y, right? I mean, obviously, it's just xy, whatever that is. But here, if I did square root 2 times square root 3, it's just 2 times 3, so it gets me the square root of 6. Okay? And then I'm going to go ahead and put this over 2, because that's what I have on the bottom, 1 times 2. So here, those 2's are going to cancel out, and that's just going to leave me with negative square root 6. And so what I'm going to go ahead and do is come back on over here, and that means that over here, I'm going to have that I value is going to be a negative square root 6. Negative square root 6. Okay, so if I come back and look at what I've got right here, I can simplify a little bit here. This 2 divided by 2 cancels out, and that leaves me with a square root 2. And right here, I have I times negative square root 6, and this is a plus, so this becomes minus I square root 6. And there's my answer. That is written in complex form. All right, let's look at this last one right here. So in this one, I'm going to go ahead and say I've got forces negative 3 pi over 2. So that's going to be 4 cosine negative 3 pi over 2 plus I sine negative 3 pi over 2. All right, if I go ahead and put my exact values in here for what those are, cosine at negative 3 pi over 2 is 0. And then I have plus I. Sine at negative 3 pi over 2 is 1. So 4 times 0 is going to get me 0. And then 4 times 1i is just 4i. So really, this simplifies down, and in complex form, it's just simply 4i. That's it. That's my standard complex form for that one. All right, so now we're going to go ahead and look at something else here. So I have these equations down here to multiply complex numbers in polar form and dividing them in polar form. That's what we're going to go ahead and do right here. Notice that what this is saying right here, if I'm multiplying a complex number when it's in polar form, I take the r value of both of them and I just multiply them together, just like I take the theta of both of them and add those together. If I'm dividing them when they're in polar form, then I take whatever equation I have in my numerator, and I'm taking the r that's in my numerator and dividing it by the r in my denominator. Likewise, I'm taking the theta that's in my numerator and subtracting the theta that's in my denominator from that to get these angle measures right here. So let's go ahead and see what we've got right down here. If I was given this right here, it's giving me two values that are in complex polar form right here, or our standard polar form is what I should say. And so this is what I have. 2 says 2 pi over 3, and 8 says 11 pi over 6. So let's call this Z1 and call this Z2. So if I'm going to do Z1 times Z2, that means I'm taking this and multiplying it to this. And that means that I'm going to do R1 times R2. And then I've got cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Okay? So if I look in what I've got here, that means my R1 is this 2 and my R2 is this 8. So I have 2 times 8. And then cosine, well, theta 1 plus theta 2, well, here's my theta 1 and here's my theta 2. So that means I've got 2 pi over 3 plus 11 pi over 6. I'm going to go plus I sine 2 pi over 3 plus 11 pi over 6. Well, if I do that, let's go ahead and figure out what I've got. If I have 2 pi over 3 and I'm adding 11 pi over 6, that means that I've got to multiply this one by 2. So it's really 4 pi plus 11 pi. That gets me 15 pi over 6. Well, that can be reduced. They can both be divided by 3. So that gets me 5 pi over 2. So what I've really got here, once I multiply these, I have 16 times the cosine of 5 pi over 2 plus I sine 5 pi over 2. And that is all I need to do. I've multiplied that and I've left this in our polar form, and that's what I have now. It's a lot easier than taking something and multiplying it out if it's in complex form. All right. Now, this says right here, redo example 7. I haven't already done example 7, simply because, to be honest, these problems, they work out really ugly. So I kind of wanted to show you this first. So let me come back up here. What this is showing me here is I've got these values here as 3 minus 4i and 4 plus 4i. If I had these and I went ahead and multiplied those out, following rules that you previously did in like Algebra 1 or Algebra 2, that would be simply just doing 3 minus 4i times 4 plus 4i. And so now I needed to use, box method, FOIL, whatever it is that you normally use. This is where you would actually get, let's see, you'd have 3 times 4 is 12. 3 times 4i is going to get me 12i. Negative 4 times 4 is negative 16i, and negative 4i plus 4i is going to get me negative 16i squared. And then what you would have to do is you'd have to remember, since you've multiplied these out, you have to combine like terms. And you must also remember that I squared is equivalent to negative 1. So if I have negative 16 times negative 1, this right here really just becomes positive 16. So I'm going to have instead here, I'm going to have 12 plus 16, so that's 28. And then I've got 12i minus 16i, and so that's just going to get me negative 4i. Okay, so that works out nicely to get it into standard form, and I should say standard complex form. Now, I could convert that over to polar form. And polar form for this one right here would just be finding what your R value is and then your theta and doing all of that. So that would just be the square root of 28 squared plus 4 squared. Well, I can't do that without a calculator because I mean, I guess I can. It just isn't necessarily fun to do 28 squared and have to remember how to multiply that. But that's going to get you 784. And then when we add 16 to that, that gets me 800. So this is the square root of 800, which I should know that I can reduce that because 800, I can take out a perfect square of 100 8 times. But I can go even further than that, and I can actually pull out. So that's no different than having 400 times 2. Well, the 400 times 2, that gets me 20 square root 2. Okay. And then my theta for that one would just be arctan -4 over 28. Well, I have no idea what that is without a calculator. And so if I was to write this into complex polar form instead, I would now have 20 square root 2 cosine arctan -4 over 28 plus I sine arctan -4 over 28. It's ugly, but that's what I have, and I keep it exact without a calculator. Okay. That's how I would do something without a calculator and multiplying that. Now, one of the things that you'll realize as you go through some of these problems is that it's easier for the most part to go ahead and convert it over into polar form and then apply these rules for multiplying or dividing. Okay. I definitely recommend that you convert first and see what you get. And in fact, that's what we're asking you to do on any problem that you receive on your test or quiz. You are not to distribute it out by, doing box method or FOIL. You're not to do that. Just like you wouldn't do division and multiplying by the conjugate. That's not what you're going to do for these. Please convert them initially to that complex polar form, and then apply these rules right here. Okay. Let me go ahead and finish number 8 here and do this as it also wants us to find the quotient. So I found the product. Let's find the quotient. So let's do Z1 divided by Z2. Okay. So if I do Z1 divided by Z2, let me do it off to the side here. So if I do Z1 divided by Z2, that means I'm doing R1 divided by R2. And then I have cosine, and then it's theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay. Something important to note, this is when I have Z1 divided by Z2. If I did Z2 divided by Z1, then that would be R2 divided by R1. And that would be cosine theta 2 minus theta 1 plus I sine theta 2 minus theta 1. So it's important to pay attention to what's in your numerator, what's in your denominator, okay? So in this case, we're going to do the Z1 divided by Z2. So my R for Z1 is 2. So I'm going to do 2 divided by the R in my Z2 is 8. And then I'm going to go cosine, and then theta 1 was 2 pi over 3. And theta 2 was 11 pi over 6. Okay, now I just need to simplify what I've got here in my parentheses for my angles. So if I do 2 pi over 3 minus 11 pi over 6, Same as this one, I got to get a common denominator, so I got to multiply by 2. So now I've got 4 minus 11. And so 4 minus 11 is negative 7 pi over 6. So I'm going to go ahead and reduce right here. 2 over 4 is 1/4. And that's going to get me cosine. This one right here is going to be negative 7 pi over 6. So this is cosine negative 7 pi over 6 plus I sine negative 7 pi over 6. Okay? And that way I could actually, if I wanted to, because this is the angle measure is on my unit circle, I could actually double check and make sure that I did everything correctly. It's just honestly kind of ugly to do that. Don't recommend it. Unless you have enough extra time because you've already finished your test and you're just checking your answers. But yeah. So what I've got here is the process that I'm going to want to do. I'm not going to lie, this this set of notes here can be a bit confusing in terms of how everything's done. It's hard to determine what's easier because sometimes one method is easier than the other. I'm just going to go ahead and tell you to default, for the sake of everything that we are teaching you, default to getting everything in this format and then applying these rules that we have right here, going ahead and applying this. Doing it any other way, really, truly, it's going to leave you more confused more often than not. Okay, hopefully, hopefully I was able to make some sense of this. If not, let me know and I can try and clear up some questions that you have.